Alright, day 2 of Unit 2 is about sketching polynomials in factored form. And we're going to be looking at the terms factors, zero-slash solution, and intercept again, and what they look like when I ask for them. So factor looks like x minus a number. So if I have 2x times x minus 5 times x plus 1, our factors of that are going to be exactly what we see. 2x is a factor, x minus 5 is a factor, and x plus 1 are all factors. Now, when I talk about zeros or solutions, that's when I say x equals a number. So x equals 0, x equals 5, and x equals -1. Okay, zero solution, x equals. Now, intercept is an ordered pair, the solution or 0, comma 0. So I have 0, comma 0, 5, comma 0, and -1, comma 0. So they're all related to each other, but they look different when I ask for them. So another term that we're going to start talking about is multiplicity. Multiplicity refers to the number of times a zero or a factor appears in a polynomial. So most of the time we have multiplicities of 1 because we just have one factor of that. So like here we had 2x that has a multiplicity of 1 because we only have one 2x in this factored form. X minus 5 has a multiplicity of 1 because there's, again, only one x minus 5 factor. And there's only one x plus 1 factor, so that has a multiplicity of 1. But since we're talking about polynomials now, some of our factors are going to have a higher multiplicity, meaning they are repeated. So we can use x-intercepts to sketch polynomial functions. Now, I wrote it out in intercept form and standard form here so that we can talk about the degree and leading coefficient. So the x-intercepts, though, are going to be 2, comma 0, -1, comma 0, and -4, comma 0. And I want to plot those first. -4, comma 0, 2, comma 0, and -1, comma 0. And I'm making them big and bold so that they stand out. Now the degree value, we know that in standard form, the degree is the highest exponent. Oops, odd. But in intercept form, what we do is we add up all the exponents here, because there's an invisible 1 here, x minus 1 to the first power. Sorry, x minus 2 to the first power, x plus 1 to the first power, and x plus 4 to the first power. 1 plus 1 plus 1 is 3, which is our degree. So in factored form, we add the exponents to get our degree, but in standard form, it's just the highest one. Our leading coefficient is positive because there's no number in front. So we know an odd degree and a positive leading coefficient means as x approaches -infinity, y approaches -infinity, and as x approaches positive infinity, y approaches positive infinity. So now we're going to graph this. So I start with the end behavior. The left side is going to go down and the right side is going to go up. Now we have to figure out what happens in between. And what happens is that we cross here, we turn down and we cross there, and then we turn back and cross up. So we cross the x-axis at each of our x-intercepts. Now you may be wondering, well, how do you know that it only goes this high? How do you know if it doesn't go up there like that? It doesn't matter how high you go, just make a smooth curve. We got to come back down, make another smooth curve, and we got to come back up. Now, once we start doing more of these, it'll be easier, like it will make a lot more sense about why I cross the x-axis here, here, and here. Turning points. Turning points is where we have a minimum or maximum, or we change directions from increasing to decreasing. So our function is increasing, and then it decreases. So here is a turning point. Then our function is decreasing, and then it goes to increasing. So that's another turning point. We have two turning points. So if a factor is linear, a linear zero, which means multiplicity of 1, the graph crosses the x-axis at that point. So crossing means we go through it, like you're crossing the street. You're on one side of the x-axis, and then you go to the other side of the x-axis. So right here, our y values were negative, and then after the 0, they were positive. Here, we crossed the x-axis, our y values went from positive to negative. So a cross means our y values change sign from positive to negative. Now this one, notice how we have two of them that are squared. Our x-intercepts are going to be 2, 0. So I'm going to plot that. And negative 1, 0. Negative 1, 0. And our degree is 4 because 2 plus 2 is 4, and I also wrote it out in standard form there, which means we have an even degree. Our leading coefficient is negative, so that means both ends are going to go down. So as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y also approaches negative infinity. So both sides are going to go down. Now, before we do the number of turning points, if we have an even multiplicity, so if the factor is quadratic, so even multiplicity, then the graph bounces. The x-axis bounces off, let me rewrite this, bounces off the x-axis at that point. So what that looks like here is in our graph, instead of doing what we did in the last problem, going through a cross, it bounces. So it touches the x-axis and then it comes back down. Well, we have to eventually turn up and touch right here, and we should bounce off this one too. Okay, a bounce, we're not changing the signs of the y values. We're staying below the x-axis. And you can see we have 1, 2, 3 turning points. So if we have an even multiplicity, our graph bounces off the x-axis. It touches it and it comes back. Like if you throw a ball at the wall, it hits the wall and then it comes back. That is a bounce. So on this page, we have two problems where we have bounces and crosses. Our x-intercepts here, negative 5, 0, and 2, 0. So I'm going to plot those. So 2, 0, and 1, 2, 3, 4, 5, negative 5, 0. Our degree value, we have a 2 here and an invisible 1 there. There's no x right here, so we don't count anything for that. So it's a third degree function, which is odd, and a negative leading coefficient. So that means as x approaches negative infinity, the left side, the y values go up. Whoops, go up to positive infinity. As x approaches positive infinity, y approaches negative infinity. So the left side goes up and the right side goes down. Now, the 0, -5, 0, has a multiplicity of 1, which is odd. So our graph goes through the x-axis. Now we have to come up and touch that light blue 0. So at some point we have to turn, come up, and we touch that x-intercept at +2, 0. And because this has a multiplicity of 2, we need to bounce and come back down. But since we drew our end behavior correctly, it automatically does that. So then the number of turning points. We have a turning point right down here somewhere. That's 1. And then +2, 0 is another turning point. So we have 2 turning points. A turning point is when we change directions. A turning point is when the graph changes directions. This one here, because we have an x in front, that means one of our intercepts is 0, 0. Then we have x plus 3, so -3, 0. And then +4, 0. Our degree value, 2 plus 1 plus 1 is 4, which is even. And we have a positive leading coefficient, so both ends are going to go up. So as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches positive infinity. So both ends go up. Now the red 0, -3, 0, has a multiplicity of 1, an exponent of 1, which is odd, so we cross the x-axis there. We come back up and touch the intercept at 0, 0. That intercept has a multiplicity of 2, which is even, so we come back down. And then we come back up and touch the purple 0, which has a multiplicity of 1. So we cross, because 1 is odd, and we go through it. Now, the actual number of the 0, meaning like the purple one, 4, 0, that 4 doesn't tell us if we bounce or cross. It's the exponent, the multiplicity. So yeah, 4 is even, but that's not the multiplicity. The exponent is. So then how many turning points do we have? We have a turning point here, here where one of the zeros is, and here. So we have 3 turning points. So many polynomial functions don't have a max or min, but instead they have what are called relative minimums or relative maximums, which means that that is the max value in that area. It is a turning point. These are the y-coordinates of the turning points of the function. So if our function has a degree of n, what that means is that there could be n possible zeros, but n minus 1 possible turning points. If we look at these, the degree is always bigger than the number of turning points. And for all of these examples, the number of turning points was 1 less than the degree. That's not always going to be the case, but the number of turning points cannot equal the degree value. So if we look at example 3, what is the maximum number of turning points the graph could have? Now this is in standard form, so don't add up all your exponents. Our degree is 4. 4 minus 1 is 3. All right, letter B, we have a degree of 3. 3 minus 1 is 2. And then in letter C, our degree is 5. 5 minus 1 is 4. So again, you don't add the exponents in standard form. You just look for the largest one. Right, so then, like I said, given the graph, the least possible degree would be the number of zeros you have. So n. So if we look at this, we see what is the least degree that each polynomial function could be. So one of the easy ways would be to count the x-intercepts. 1, 2, 3, 4. Okay, so you may think 4, but then you need to check n behavior. 4 is even, so the n's have to be going in the same direction. Both n's are going up, so the degree has to be even, and we have 4 zeros. So the least possible degree is 4. Letter B, you may say, okay, we have 1, 2 zeros. The least possible degree has to be 2, but the n's go in opposite directions. One n goes up, the other n goes down. So what that tells us is that the degree has to be odd, and since we have a bounce right here, that means the multiplicity must be even. So the smallest possible degree this could be would be 3. And finally, we're going to create some things. Create a polynomial function that has 3 x-intercepts and the following n behavior. The left side goes down and the right side goes down. So I'm just going to make 3 parentheses because that has 3 distinct zeros, but this has a degree that is odd right now because we have invisible ones here. So the n's would go in opposite directions. So I need to change one of these to a 2. So now that my degree is 4, 1 plus 1 plus 2 is 4. And since both sides are going down to negative infinity, I need to have a negative in the front. So the reason this is a 4th degree function, leading coefficient is negative. So both sides are going down. So then you can write the explanation in your own words about, the intercept 6, 0 has an even multiplicity, so it bounces, whatever makes sense to you. All right, now write a polynomial function in standard form that has a maximum of 4 turning points in standard form. Okay, so we need a 5th degree function because a 5th degree function could have a maximum of 5 minus 1, which is 4 turning points. So I'm going to 3x to the 5th plus 5x squared minus 2x plus 1. Just making things up, but as long as my largest exponent is 5, then I can't have more than 4 turning points. And then this last one, write a possible equation for the graph shown and explain. So I'm going to start with both sides going down, so negative, and then our zeros are at 1, 0, so x minus 1 will be a factor, and x minus 3 will be a factor. Now, because our graph bounces off the x-axis at both of those points, our multiplicities have to be even. So we could have them both be 2's. We could have one be 2. We could have the other one be 4. It doesn't matter as long as both multiplicities are even. All right, so this was a lesson on sketching polynomial functions. We're going to revisit this, but you need to make sure you understand the vocabulary, turning points, crosses and bounces, leading coefficient, degree. So if you need to watch this again or watch certain parts of it again, you should definitely do that. It's very easy to mess things up on this, especially if you're not watching the entire video. So please make sure you go back and review anything that you need to. Thanks for watching the video. Make sure to like it and subscribe.